Good morning. This is A0762, English Track 2. Now we'll start today's morning session, session number 6. This session talk is Mathematical Optimization and Python by Yosuke Onoue. Please.
Thank you. I'd like to talk about mathematical optimization and Python. Before starting, this is my first English presentation in public place. Thank you. I'm not good at English, and I'm so strained now. Okay. First, who am I? I'm Yosuke, and this is my Twitter ID. I'm from Osaka, and I'm a PhD student in Kyoto University. I'm from here, and I study here. And I talk about my specialty. I belong to Graduate School of Engineering. I specialize in decision support. I studied in master course. I studied optimization, and now I study visualization. Of course, I love Python, and also I interested in HPC technologies such as GPU. I hold GPU seminar in Osaka, and 1 year ago in PyCon JP 2012, I have a session about PyCUDA and PyOpenCL using GPU from Python and in free space. Someone said to me, "You talk about GPU, but my topic is not GPU optimization." Now, I'm writing JavaScript to implement visualization application in web apps. Now, I'm developing supporting tool for revealing evaluation structure to quantize human factor. It is most of this source code is JavaScript, but backend server is implemented in Python using Google App Engine. And okay, move to main topic. In my master course, I studied optimization. So I developed optimization problem solver. First, I implemented all of the software in Python, including user interface and algorithm. But optimization algorithm is so complicated, and Python is not faster enough in this field. NumPy or SciPy and other libraries did not match my field, unfortunately. And I tried to Python and multiprocessing, but I could not achieve enough speed up. Next. I decided to implement this algorithm in OCaml because first I chose Python because high productivity but it is not enough speed, but OCaml have better performance than Python because it's native language, and it is also high productivity, but too difficult to communicate OCaml from Python. Then I developed interface to communicate between Python and OCaml named OTypes. It wrapped OCaml C interface using C types. But OCaml, unfortunately, OCaml, I want to implement my algorithm in parallel. Unfortunately, OCaml support only multi-process programming, not support multi-thread programming. Then, finally, I decided to implement my solver in C++. It is not so easy to run C++ and boost Python. But now I like them. I achieved enough speed in C++. Yesterday, some session mentioned about Python to communicate C++ and Python. I'm interested in it. I'll try it. Okay. And why my application layer? Why I use Python in application layer? It is very useful to analyze algorithm and analyze data. This is one of my script. Optimization algorithms is so complicated. That is very complicated combination of some subroutines. Then, and there are many parameters to improve performance. So compiled language is not suited for this usage. Okay. In optimization algorithm is very complicated. So the algorithm is used as a subroutine for more difficult algorithm. And there are many parameters. Then optimization researcher have to implement a new algorithm using existing algorithm. And also have to analyze the effectiveness of algorithm. Then Python is suited for science in this field. Okay, now I reintroduce mathematical optimization. Software programmer knows many optimization. Improving software performance is not mathematical optimization. Reducing memory, compiler optimization, search engine optimization. They are not optimization, mathematical optimization. What is mathematical optimization? It is theory and techniques to model and solve optimization problem. There are many applications in engineering and computer science and management science. So before mathematical optimization called mathematical programming, but recent year mathematical programming society renamed to mathematical optimization committee. Then now this mathematical optimization is sorry. Okay. Okay. Next, I introduce optimization problem. What is optimization problem? Common form of this problem is find the best element from some set of available alternatives. This figure shows image of optimization problem. Feasible region means available alternatives. And element of that region is solution. And find, this is objective function. We want to maximize this function. Then maximized point is optimal value, and so that solution is optimal solution. Basic mathematical form is here. But this is very common in the abstracted form. In there are very variation of optimization problem. Type linear or nonlinear, and convex or non-convex, differentiable or non-differential, continuous or discrete, single objective and multi-objective, constrained, non-constrained, and so on. Then today, I talk about one of the most common formulation of mathematical program, optimization problem. This is mixed integer programming model, or MIP, so-called. This is one of the most basic model. This includes linear programming model and integer programming model. This is have linear objective function and linear constraint function. Then this model has mix of continuous and discrete decision variables. And to solve this problem, there are some high-performance software solvers, but such as Cplex and Groby. But such they are commercial software and too expensive, about over 100 million, 1 million yen. But for academic, we can use them freely. And this is example of a linear programming model. A kind of MIP. Now we are manager of factory. We producing two products, P1 and P2. And unit profit is this. Produce P1 1 ton, it makes 2 million yens, and also P2 makes 5 million yens. These products made from 3 materials, and this resource consumption is this table. But we are limited resource. Then, what is optimal production plan to maximize profit? We want to get more money. Then, how to solve these problems? This is an easy case, but in real world, there are many variables. For example, this case have only 2 products. In real world, there are 1,000 or 10,000 or more products. That in that situation, we can solve optimization problem by using hand without computer. It's not we can't solve without computer. Okay, usually mathematical programming optimization problem solve using computer and software solver. First, we model real problem as mathematical model, and mathematical model we convert mathematical model to input data format and run software solver. Then we get solution and solve real problem using this solution. Okay, next, optimization and Python. Recent year, Python become famous in optimization community. There are some open source projects in this field. Cooper is one of them. This is common optimization Python repository. This includes some sub-libraries such as Pyomo and PySP, and more than 10, about 10. And commercial solver introduced Cplex, such as Cplex and Groovy, has Python interface to control solver from Python. And then I introduced Pyomo to modeling real problems. So before then, I show Groovy command line. Okay. We can run Groovy from console. Run groovy.sh. Groovy shell implemented as Python interpreter. I surprised. Okay. Right? Groovy? Import. Oh. Okay. Pure Python interpreter, maybe. Okay. Yes. Okay. Reintroduce Cooper Pyomo. Pyomo is Python optimization modeling object, sub-project of Cooper. How to install Pyomo? Use pip. Usual modeling language. There are some algebraic modeling language such as AMPL and AIMMS and GAMS. It abstract of solver dependent input format, but they are specific syntax, and some of them are commercial software. We have to pay money. Then, advantage of Pyomo. Pyomo is open source library, and this implemented as a Python module. We don't have to learn new syntax. This implemented as a Python module, so we can integrate with solver and application using mathematical optimization easily. Okay, revisited LP linear programming example. Now, let's solve this problem using Pyomo. Okay, first, I introduced modeling methodology. First, determine decision variables. And next, determine object. And last, determine constraints. Okay, following this methodology. First step, what is decision variables? That problem. We have to decide amount of P1 and P2 to produce. It's described as X1 and X2. And step 2, what is objective? We want to maximize profit. Then, profit is described as unit profit of P1 times amount of production producing P1 plus unit profit of P2 and times amount of P2. Okay, third step, what is constraints? We can only limited resource. Then unit consumption of M1 for producing P1 and times amount of P1 plus unit consumption of M1 for producing P2 times amount of P2 less than or equal to available resource of M1 and X1 and X2 must non-negative. We can't produce -1 ton of products. Then we can get these equations. This is two-dimensional problem. We can plot plane them. Light blue region is feasible region, and red line is objective function. We want to maximize profit, move objective function higher. This case, we can solve this problem using these method, but in real case it cannot solve without computer. Then introduce Pyomo. Basic usage of Pyomo. First, initializing model. Import Pyomo, then create model. Pyomo has concrete model and abstract model. Abstract model can separate model and data, but this case did not need to separate them. Then now use concrete model. We have to customize model. Finally, model.create. We can go to instance, and Pyomo can solve instance. Okay, now we customize model. First, we set decision variable. Pyomo bar is definition of the decision variable. Option within is means domain of these variables. Some kind of domain, non-negative reals or reals, it is default. And binary, integer, and non-positive integer, and so on. Okay. Next, we define objective function. We can use Pyomo objective. It's definition of objective function. There are two kinds of optimization problems. Maximize and minimize. We can use sense option to set the type of optimization. And objective function is described as these arguments. Finally, we define constraints. Now, there are three constraints. Now we have three materials. We can use Pyomo constraint. It is define of constraints. Basic usage is same to objective, but this is conditional operation. Okay, finally, we got this source code. Then, okay, I execute this program. We can get this output describing models. And to solve this problem, using Pyomo command, Pyomo command call solver, then we got solution. Maximum profit is now 23.5, and detailed output is saved as result JSON. we can get following information. Okay. We can solve this model also from script. Using opt module. Solver instance, method of solver instance, solve, and past instance. Then we got result. Okay, this is result using from Python script. Okay, I introduce more case study. This is my most favorite optimization problem, knapsack problem. Select the project to maximize profit subject to budget constraints. There are 7 projects, and P means profit, and W means cost. We have only 9 budget. What is optimal selection? To to solve this problem, first I decide what are decision variable. Now I use discrete variable, especially Boolean variable. It has 0 or 1 values. If xi is 1, ith project is selected, and 0 is otherwise 0. Next, objective is maximize total profit. We can write this source code. And what are constraints? It is total cost is not exceeded budget. Following source code. And finally, we got this source code to solve knapsack problem. Now I separate model and data. This source code does not have data. Another file, I prepare another file to define data. Run this script. Using I use Pyomo command. And data is defined in that file. And other data is also defined. We run, I run one of them. And next, we solve another data. We got different result. No editing script file. Okay, we solved knapsack problem. Next, Sudoku puzzle. This puzzle also can solve using mathematical programming. Do you know this puzzle? Okay. Some trick to define decision variable. I introduce a variable, 0, 1 variable to define number in some cell. I describe the variable yijv. It means in cell ij is v, then 1, and otherwise 0. In this case, in this cell, we put 7 in this cell. Then y447 is 1. And we consider objective and constraints. What is objective? In Sudoku puzzle is have not objective to maximize or minimize. We want to know feasible solution. Then we use dummy objective. And what are constraints? Two kinds of constraints. Each cell have one number. It is not allowed in y447 is 1 and y448 is 8. Only one number located in one cell. This is first constraint. And next, Sudoku puzzle rule. Each row and each column and each box contains all of digits from 1 to 9. Okay, finally, we got this source code. Real complicated Pharma one, but puzzle board is defined here. Okay, now I run this script. Okay. Okay. We got solution. Easily. Yes. Sure. This is power of mathematical programming. We don't need any knowledge to solve this problem. Okay, finally, conclusion. Mathematical optimization solve many real problems, including Sudoku puzzle. Many kind of problem can solve. And Python is suited for this field. I introduced Pyomo to model optimization problem. Okay. let's try optimization using Python. Finally, I introduced two books about Python and optimization. Okay, yeah, thank you.
Very much. Thank you, and nice challenge first English presentation in PyCon. So, any questions or comment?
So first, you mentioned that you rewrote your optimization engine from Python to OCaml, and after that you rewrote it into C++. Yeah. But after that, you just introduced existing framework. So what is it connected to? Is it another story?
Another story.
Really? So I have another question. So actually, I'm working on the optimization problem myself, and I'm very interested in your talk. And I also have sometimes have a temptation to rewrite code into OCaml or other language, because I also can write OCaml and C++. But the problem is whether it is worth doing it. I mean, you have to estimate how fast it can be. So how do you decide to rewrite your code?
In C++?
Yes.
Big reason is I want to use C++ libraries. So,
you use library?
Parallel computation library or GPU library.
I see. So you before rewriting all the code, you tested very small code to estimate the speed up.
Yeah.
I see.
Thank you for a good presentation. So my concern is genetic approaches, not mathematical. Do you know genetic, identity shuho? Do you know Python package for genetic approach?
Okay. I introduced exact method to get optimal solution.
Name or
then
on the Cooper registry?
no.
Let me know your exact name after session. So my comment to your approaches. My working for industry. Industry require more and more complex optimization.
Yeah.
So mathematical approach is a pitfalls. Showing a second of all graph. Please show me your maximize point that to a local maximum point. Many cases will focus on your local maximizing, not global optimization.
Sure.
So it's a main industry problem. So genetic approach or annealing approaches or heuristic approach are getting a general global optimization point. So precise point or mathematics. Mathematics are many or many complex approaches. So linear is very simple. Industry, so it's my comment. Yeah. Good area.
I'm trying to solve nonlinear function. Of course.
どうも発表ありがとうございます。先ほど、GA の Python のソルバーがないかという話ですけれども、PyOpt という
のがありまして、その中にGA 含んで20種類ぐらいのソルバーが入っております。
あと GA 専門でいうと PyESP ってあったと思います。ちょっと思い出しました。
すいません、あとちょっと宣伝っぽくなるんですけども、一番最後のスライドに新しい数理最適化という本がありましたけども、応用数理学会のオンラインマガジンに新しい数理最適化の書評がありますので、本について知りたかったらぜひ応用数理学会のホームページをご覧ください。すいません、もう一個宣伝なんですけども、今回Python で最適化ということなんですけども、Excel を使って最適化をするというセミナーがですね、9月20日に OR 学会、オペレーションズリサーチ学会でありまして、学生さんは無料ですので、まだ申し込み半分ぐらい空いてますので、もしよろしければ9月20日のオペレーションリサーチ学会の OR セミナーというところで、Excel を使った最適化というのがありますので、よろしかったらご参加ください。はい、すいません。
His question it was he pointed out there is a Python-based package PyOpt, and it includes such optimization algorithms and genetic algorithms. And あと he pointed two comments that was mainly for Japanese people. Japanese advertisement of book or advertisement of some workshop on mathematical programming. That's additional information from me. So, and he replied single package name. What is the package name?
PyEPS or
PyESP. PyESP.
Evolutionary
Programming or something.
Okay.
I have a simple question. You said that you really liked integer programming problems, and the NP hard knapsack problem. There's not much to like about it. What is it that makes you like them so much? I hate them. Why do you like integer programming problems? What's so interesting? Why do you love them? You said you. Okay.
My professor likes this problem.
Just asking. Okay.
Okay. Any more? So I'd like to close the session. Thank you very much.